Okay, so you can do scalar multiplication by distributing and multiplying it through. You can also multiply matrices together. Now, there is a process when you multiply matrices together. So when you multiply matrices, you have to, so I don't know, we're going to use A by B and C by D, whatever those are, like those values of this matrix. In order to multiply the matrices together, these two inside have to be the same. Those have to match whenever I'm looking at it. So, if I were smart, which that's debatable sometimes, I should have put that as a B, so you see B and B. So the two inside values have to be the same. For instance, if I have a 2 by 3 and a 3 by 1, as long as these are the same, that's the key. If those are the same, then you can match it. The outside dimensions, this is going to be the dimensions of your new matrix. So that's it. So as long as the insides match up, then the outsides are going to be your new matrix. That's all there is to it. So let's do an example so you can see what's going on here. And it's just a pile of distributing is all it is. It's just distributing it through, but those two have to match. Because, such as if I have example 7 here, where A is -3, 4, 2, and 5, 0, 4. B is -6, 4, 2, 3, 3, -2. Then you're looking and I want to take A times B. I don't want to put that. So I don't want to put a, so here's where I'm with this. So I'm just going to write the product of AB. So here's my struggle. So normally we put this, oopsie daisy, this, and then that one. This is in Calc 3 is called the dot product, where you have to do two matrices together. If you do something like this, it's called the cross product. So I don't really want to introduce that notation to you, because when you get into Calc 3, it's gonna be something different. So if I'm just gonna have this, I'm gonna write the product of A and B, because we're just multiplying these together. Product of A and B. So we'll just go with that, okay, for now. For right now, you can put those symbols in there. Honestly, it won't be as big of a deal, and then you'll learn what they mean later. But anyway, so the whole point is, if I have A, that's a 2 by 3 matrix, and B is a 3 by 2, right? So our whole point, oh my goodness. Yeah, 3 by 2. So our whole point here is the fact that my two insides match up. That means it's even possible. That's all that means, that one is even possible. So then my new matrix is going to be a 2 by 2 matrix. So if I'm going to multiply these together, so I've got -3, 4, 2, 5, 0, 4. And I am multiplying that by -6, 4, 2, 3, 3, -2. When I multiply these two matrices together, you are going to take this row and multiply it by this column. So you're just going to basically pick this up and put it next to this one. For instance, if I have this, would be -3, 4, and 2. Do you see what's happening there? I'm picking up this row and I'm bringing it over. The first term times the first term, second terms times second term, third term times the third term. That's why if I have these columns, they have to match up with these rows, because I am matching up then each column here on the top with the row. So when you make your new matrix, 98% of success in mathematics is organization, right? I know that my new matrix is going to be a 2 by 2, so I'm going to set that up. And when I set that up, I know up here, this is my top left. So I'm going to get my top and then the left is what's happening. So with that top left, I'm going to multiply each one of those pieces together. So -3 times -6, right? The two top ones, -3, -6, plus the two middle ones, plus the last ones, 2 times 3, right? Scoot that one over a little bit here. So there's my top left. Then, if I want to go for my next piece over here, this is the top right. So I'm going with the top again, but I'm going to multiply it by the right. Do you see what's happening here? -3 times 4 plus 4 times 3 plus 2 times -2. Every term in the top matches up with the term on the right one. All right. Then if I have bottom left, I'm going to take the bottom left column. Do you see? So it's just a distribution problem. When you set up your new matrix, you know exactly where it is. So my bottom will be 5 times my left here is -6. And then I have 0 times that 2 and 4 times the 3. So it's really not a big deal. It's just whatever it is. So this is bottom left, bottom right. And so you just line up those different ones. So I have the bottom to the right. All right. So 5 times 4, 0 times 3, 4 times -2. The biggest thing here is you're just taking the first term in the bottom and the first term in the column. The middle term in the bottom, the middle term in the column. The next term and the next term. And then you just put those together. So I have 18 plus 8 plus 6, which what is that? 32, is that right? Because I really have 18 plus 14 is 32, I believe. Let me check with old flunky butt. Yep, 32. So my answer is now 32. Here I have -12 plus 12 minus 4. So that's just a -4. -30 plus 0 plus 12 ends up being a negative 18. I was looking at the wrong thing for a minute and I had -18 in my head, but I was looking in the book. I was like, what? Okay. Slow and steady wins a race. 20 plus 0 minus 8 will give us a 12. That's what I get for checking the book instead of just doing it myself. All right. That's it. Our answer is a 2 by 2. And then it works out that we have that. All right. Okay. If they don't match up, then you can't do it. And the other thing that I want to point out is this is not commutative. So if you have the product of A times B, that is not the same as the product of B times A, right? So let's look at this. So let's just call this part A, even though the book doesn't have it. Let's call this part B. I want to do B, and I'm just going to write it, B times A here that we're looking at. Well, if that's the case, my B here is a 3 by 2, and my A is a 2 by 3, right? These match, so we're good. My new matrix for this one is going to be a 3 by 3. Are those going to be the same? So this one, my product is a 2 by 2. This one, my output's a 3 by 3. So do you see how they're not the same there? Okay. All right. Very good. Now let's just do this one really quick because it's here. So let's put it to this. I'm going to swing it over here to this next page because we obviously ran out of room. So cut this and paste it over here. And let's do this thing. So B, let me look at my other paper since I have it on the other page now. I'm going to go black. Is negative 6, 4, 2, 3, 3, negative 2. And I'm going to multiply that by negative 3, 4, 2, 5, 0, 4. All right, this would be a good time in the video for you to pause the video, and this is the beauty of the video, right? Pause the video, do this one on your own, and then you can come back and see how it was done. So if you want to pause it, do it on your own, and then I'm going to keep working it, obviously. And then you can start the video back up again, and you can see how it works. Pardon me. Okay, so then this is the top left. So I'm going to take negative 6 times negative 3 plus 4 times 5. I'm going to have to make these bigger. I was hoping to stick those in there, but I was just doing that for demonstration earlier. Okay. Now just keep on rocking it through. I'm going to do then the top middle. Negative 6 times 4 and 4 times 0. Then the top right. Negative 6 times 2, 4 times 4. Then the middle left. Middle left. 2 times negative 3, 3 times 5. 2 times 4 plus 3 times 0. Oops. Got an extra little parenthesis in there. 3 times 2 plus negative 2 times 4. And then here I have 3 times negative 3, negative 2 times 5. 3 times 4, negative 2 times 0. 3 times 2, negative 2 times 4. Now, something else that I'm going to point out here is look what happens. All negative 3s, all 5s, right? Negative 3 and 5 in this first column. 4, 0, second column. 2, 4, third column. Across the top, negative 6, negative 6, 4, negative 6, 4, negative 6, 4. Do you see that pattern? Every single time. Except, good thing I looked at this pattern because you guys are probably screaming at me right now, weren't you? Here is middle left. So this should be 2 times 2, 3 times 4. I got off on what I was looking at. 98% of success in mathematics is organization. You guys are probably like, no, you messed that up. 2 and 3. There we go. See, that's also in class. You guys would have told me. Hey, wait, Bradley, look at that. 3, negative 2, 3, negative 2, 3, negative 2. All right. Very cool. Then you just do that multiplication. So I've got 18 plus 20 would give me 38. Negative 24 plus 0 is a negative 24. Negative 12 plus 16 is 4. Negative 6 plus 15 is 9. 8 plus 0, 4 plus 12, negative 9 minus 10. Oops. Got excited with that, didn't I? 12 plus 0, 6 minus 8, and that is my answer. So when you work out these problems, the A times B and B times A, as you can see, those are not the same thing. So if they are not the same thing, whenever you're looking at it, it doesn't even matter. If this would have been a 2 by 2 and a 2 by 2, and you would have ended up with a 2 by 2, just because the dimensions are the same, the values still aren't going to be the same. Okay, so in order to put these together, the two insides have to match up. If they match up, then it's all systems go. If they don't, Bam, you are done right off the bat. Dimension mismatch. There's nothing else you can do there. All right. Okay. So let's do one more and then we'll call it. Here I have example smiley face because I'm just going to make this up and not mess with that book. We have A is equal to a -2, 0, 1, 4. Why not? And B here is going to be -1, 3. All right. So this is a 2 by 2. This is a 2 by 1. If I want to take A times, oopsie daisy, B, then that's going to be a 2 by 2 and a 2 by 1. Right? These are the same. My new dimension is going to be a 2 by 1. So if I multiply these out, my new dimension is going to be a 2 rows by columns. I put that down too far. Rows by columns, 2 by 1. And I have top row, -2 times -1, 0 times 3, and bottom row, 1 times -1, 4 times 3. And we get 2 plus 0 is 2, -1 plus 12 is 11. Right? Now, let's say I want to do this same deal, but I want to do B times A. So B is a 2 by 1, A is a 2 by 2, right? Ah, very nice. Check that out. Can I even put these together? No, not possible. There's a dimension mismatch. So you see what I'm getting at there? Okay, good. All right, guys. You've got this. Keep going. This is it for 7.4, and I'll record another video then for 7.5.